This video is confidence intervals for one population proportion. So we have talked about confidence intervals for estimating a mean. Now we're going to talk about confidence intervals for estimating proportions. So some things we need to know. The sample size is still n. The number of people who respond in the desired way is x. So what do I mean by that? So if I said what is the proportion of people in our classroom who wear a yellow shirt. So it would be the number of people wearing a yellow shirt. The sample proportion is p hat. This right here is the notation for p hat. We call it p hat because look, it's a p with a little, looks like it has a little hat. So p hat stands for sample proportion, and you find that the same way that you would find relative frequency. Basically, you find the number of people that respond in the desired way and divide it by the total. So p hat will be our point estimate that we will use at the beginning of the formula. And remember, for confidence intervals, we take the point estimate and then we add and subtract the margin of error. So to find the margin of error, we need a critical value, which we're going back to the normal distribution, so we'll do a z. So you'll find that the same way we did for z intervals, the I and V norm, or you can use the table. And then we multiply that times our standard error. So the standard error for proportions looks a little bit different than it does for means. It's the square root of p hat times q hat over n. Now p hat we said was x over n, so what is q hat? Q hat is the complement of p hat. So q hat is 1 minus p hat divided by n. Make sure you do all of the inside before you square root. So we assume for this that the population is at least 20 times larger than the sample, and that the sample contains at least 10 people in each category. This is the actual formula. Point estimate plus or minus the margin of error. The point estimate is p hat. Plus or minus the margin of error is found by multiplying the critical value times the standard error. The critical value in this case is a z. We're no longer doing the t's. We only do t when we don't know the population standard deviation and we're trying to estimate a mean. So z times our standard error, which is square root of p hat q hat over n. So it looks like a fun formula. So let's jump right in. The Nielsen Company surveyed 225 owners of Android phones and found that 160 of them plan to get another Android as their next phone. Construct a 95% confidence interval for the proportion of Android users who plan to get another Android. So since we're doing a confidence interval for a proportion, we are going to use the formula p hat plus or minus the critical value z times the square root of p hat q hat over n. So I'm going to go up to the top. I'm going to write the things that we know. So p hat is the sample proportion of owners of Android phones who plan to get another Android phone. So that would be 160 out of 225. Now please note the top number is always larger. The top number is always smaller than the bottom number. Okay, if you want, you can change this number to a decimal. You can leave it as a fraction, or you can change it to a decimal. If you change it to a decimal, you need to go out at least 4. If you change this to a decimal, you get 0.7111. Q hat is 1 minus this. You can also do 1 minus 160 over 225. If you like keeping it as a fraction, when you subtract it, you get 65 over 225, which is 0.2889. If you subtract 1 minus 0.7111, you get 0.2889 as well. Let's see, what else do we need? Oh, we need the z. We need the z. Okay, so let me remind you how to find the z. So we draw a normal curve, a standard normal curve. 0 is in the middle. The center is our confidence level, 0.95. We're looking for this number or this number. You pick, it doesn't matter. The answer you get will be the same. It's just one will have a negative and one will have a positive. And we just need the positive version. So either one works. So if 95 is in the middle, that's 5% left over to be divvied up in the two sides. So that'd be 2.5% each, or 0.025. So we're going to do I and V norm 0.02501. And when we do that, that's just to remind you, that is second vars number 3, 0.02501. And we get negative 1.960, which we will just drop the negative off and make it positive. Alright, so let me change the color here. Let's start with p hat. P hat is 160 over 225. You can write 0.7111 if you want. Plus or minus the critical value, which is 1.960, times the square root of 0.7111. Now you can write the fraction here, but or you can write the decimal. It's up to you. Times 0.2889. You can't really see that, but that's what that says. Over the total, which is 225. Now I feel like a lot of times I don't show you the calculator, but I feel like I need to show you the calculator here, just because there's so many ways that you can enter a number. So let me pull the calculator up. So to type this in, I'm going to do 160 over 225. Clear that out first. It's 225. I'm going to start with minus 1.960. You do not have to type times, but you can if you want. But you want to type in the square root sign. The square root sign is a secondary function of x squared. So you hit second x squared and the square root sign will pop up. For some of you, it will pop up with a parenthesis. And we're just going to do what's inside 0.7111 times 0.2889 divided by 225. You don't even need parentheses in there. You just type it just like that. If the parentheses originally popped up for you, like if you have an 83, you can close the parentheses now. And then hit enter, and we get 0.65188. For proportions, we normally round these to 4 decimal places, just so that you know how to round. These. Okay, we need to do this one more time, but we need to do it with a minus. So let me show you with a plus. We already did the minus. Now we want to do plus. So what I usually do, you guys, is I usually go to the secondary function entry. If I hit second, try this again, second entry, or second enter, you'll notice my previous entry popped up, and I can just scroll over and change it to plus, so that I don't have to retype the whole thing. And this time we get 0.7703 if you round. Okay, we got 0.6519 to 0.7703. Another way to write this is 0.6519 is less than capital P, the population proportion, which is less than 0.7703. So that means that the true proportion falls somewhere between 0.6519 and 0.7703. And then we can write this out as a sentence. We're 95% confident the proportion of Android users who plan to get another Android is between 0.6519 and 0.7703. Always use the context of the problem. Don't just say that we're 95% confident that the proportion is between the two numbers. You need to define what proportion we're looking for. What kind of proportion? The proportion of what? Now, let's look at this last question. It says, assume that an advertisement claimed that 70% of Android users plan to get another Android. Does the confidence interval contradict this claim? So contradict means that it doesn't support the claim. Well, let's see. First off, it's given us we found it in proportion form, but we can convert these to percentages if we wanted. This is really 65.19% to 77.03%. So the true proportion is the true percent is somewhere between 65% and 77%. About that. Anyway, so if the advertisement claims that it's 70%, 70% is somewhere in between these two numbers, correct? So the true mean is somewhere between 65 and 77%, so that could include 70%. So does the confidence interval contradict the claim? No, because 70% is included in the confidence interval. That means that the mean very well could be, or not the mean, the proportion very well could be 70%. All right. So we have a few more examples. Let's talk about the calculator. So with the calculator, you can do proportion confidence intervals by going to stat, arrowing right to test, and choosing one prop z interval. Now that may be choice A for many of you. It's going to ask you for three numbers. It's going to ask for an x, an n, and the confidence level. Now here's the thing. X is the number that responded in the desired way, and n is the total. Okay, most of the time they'll give you these two numbers separately and you're fine. Sometimes they give you p hat instead, like they tell you the proportion of the population that responded in the or the proportion of the sample that responded in the desired way. If that's the case, just multiply p hat times n, and that will tell you what x you should type into the calculator. Now, if p hat times n is a decimal number, you need to round it to a whole number before you put it in here, or it's going to give you an error. Then we put in n, we put in the confidence level, and we calculate. Okay, we're going to stop here, and we're going to pick up with part 2 with example 2, working from home.